And we can try this demonstration. It just downloads a little demo program. So let me try to open this, run it, right? And it says on the slide that you can go to object static members and you can run this. So here's the object static members. So let's see, let's take a look at this. So we have our struct point right here defined, and it says, okay, I have an origin for x and y. I am using m underscore to name my variables here, and those two are static variables. There's also static void set origin, static function, which supposedly does what we did in that example. And so so we have essentially, this is our header file that defines struct point. Remember, struct and class is the same thing. Automatically everything inside the struct is public. So I guess I use that for this particular demonstration. So here's our implementation file. Now, I am assuming here in this demonstration that once we hit like a main function, essentially what happens here that the static variables are created even before the main function is called. Which means this, I could create a function that could be invoked even before the main function is called. And that would be if I wanted explicit initialization of those two variables. I guess let's finish with this demonstration, and then I'll do it in the code. So let's finish with demonstration. So first of all, first observation. For now, I'll just say it, and you know, those two variables are allocated and created even before the main function is called. Okay, those two. That's first point to observe. So this is our implementation file, and we have initialization of these variables, which we kind of need to add to our main demo program that we can compile. So here's the main function. So as the main function starts, we're making this call. So we're making this call into set origin, right, which is declared inside the point class. And guess what? Those the set origin 510, the parameters essentially are passed to the function 510, and they of course are assigned to these static variables. But this, remember, the static variables, this remains true, that those two static variables completely outside of the scope of any instance here. They really belong to all points, no matter how many of them are created. So back to this demonstration. Then I would like to instantiate point 1, okay, and I guess that part right here, point 1, demonstrates that point 1 with its mx and my, those are the names in this demonstration that I'm using for normal member variables. Of course, all of it lives in the local scope of main, because this is the main function. We said, okay, call set origin, something happened to this, but now we say point 1 and point 2. These two instances, you know, it's just another view of this little thing, like those two boxes here are created in the scope of main function. So those will be destroyed as soon as the main function finishes, right? But those will outlive anything that lives inside the main function. So the next one is an attempt to make an assignment, and it just basically demonstrates this. Yeah, you can use your static variables directly if they are declared public, right? So I can just say, okay, let's have mx set to mx origin, okay? So and finally, as soon as we're out of main, and the closing brace closes the scope of main, the two of these instances do disappear. They're gone. Whereas those two guys remain in place. They're still alive. They're still there. Okay? And then I guess I just kind of clear the screen after we're completely out of this demonstration. Okay? So, it is difficult to come up with good analogies in, let me just, I never timed this. You know what? Let me make sure I save this part.